Hi. Okay, guys. So welcome to this new video. This is about the addition of vectors. Okay, and so I'm going to use right now a problem that is on the exercise that we see during the class today. Okay, it says this: draw a coordinate system. Draw in a coordinate system the trajectory of a person that walks 300 meters to the north, turns to the east, and walks for other 55 meters. Calculate distance and displacement of the person mentioned. Okay, so the first thing we need to have is the coordinate system. Alright, so we'll have this coordinate system, okay, well, these two axis system in which I'm going to draw both of the trajectories that they mentioned here, well, both of the displacement they have. That is 300 meters to the north, and then it turns to the east and walks for another 55 meters. Okay, so I'm going to write it down here. Okay, this is the first one, it's 300 meters to the north, and then it says that it continues walking for other 55 meters to the east. Okay, so I'm going to write that out here. This is 55 meters to the east. Okay, so I'm going to complete this little system of vectors. Okay, going to the definition of displacement. Okay, so remember that we have these two concepts. Okay, what is distance and what is displacement? We know that distance is the length of the entire path of the motion. So distance in this case would be the addition of 355 meters, because that's the entire path of the motion of the person. Okay, but now the displacement of the object has to be, according to the definition, going from the initial position to the final position in straight line. Okay, so this is going to be the displacement. Okay, this line I'm drawing right here. Okay, so what do I have to do to measure it? I only have to use the Pythagorean theorem and establish that this is a triangle, okay, in which this side that I'm drawing with green, it's equal to the side that measures 300 meters. So this is also 300 meters. And the other one that is right here below, it's equal to the 55 meters east that I have right here. Okay, so this is also 55 meters. Okay, so now I want to obtain the hypotenuse of this triangle. So I want to have this value right here. Okay, so to obtain that value, okay, that maybe, well, perhaps you can know as the letter C for the hypotenuse, or what nature for the hypotenuse, and the Pythagorean theorem. So actually I'm going to have it like VR being like the resultant vector. Okay, so I'm going now to calculate the value of the resultant. Okay, so this is the formula that we're going to be using right here. Is the square root of the sum of the squares of the two sides of the triangle. Okay, so once that we do it, we obtain that the value of the resultant is equal to 305 meters. In this case, I'm not going to calculate the angle of this vector, so I'm just going to say that is 305 meters, right? Sorry, 305 meters northeast, northeast. So this is the magnitude of the resultant, that in this case it's our displacement. Okay? Displacement, because it is the length from the initial position to the final position in a straight line. So there we have. We need to have the distance and the displacement, and that's what we obtain right here. Distance 355 and displacement over 305 meters northeast. Okay guys, that's all for this video. See you guys on the next video.